In today's lesson, tikuda kuita a tutorial on circle geometry. We are going to be going through various ZIMSEC questions on circle geometry and see how we can best answer them. So we start with this question, written June 2019, paper 1. In the diagram, ABCD is a cyclic quadrilateral. Saka idzi dzama dzangu kuudziwa kuti we are dealing with a cyclic quadrilateral. Kureva kuti there are certain things about a cyclic quadrilateral we should know. So I just want to run a brief recall. Kuti kana tichitaura about a cyclic quadrilateral. So if you are writing notes, you might want to write this down. Saka a cyclic quadrilateral chekutanga by definition tiri kuti all four vertices, kana tichida kutaura technically, but we can just call them corners, are on the circumference of a circle. Saka kana makona ese ari 4 ari pa circumference, that is a cyclic quadrilateral. You are going to soon discover that they do not always tell you that you are dealing with a cyclic quadrilateral. Saka this property of cyclic quadrilaterals is important to identify cyclic quadrilaterals. Saka if you come here, mukatarisa this corner iri pana D yakaguma circumference, A yakaguma, B yakaguma, and C yakaguma. Kureva kuti that is a cyclic quadrilateral. If we have a quadrilateral, ndanga assume kuti everyone knows what a quadrilateral is. Of course, a quadrilateral is a four-sided shape. Shape inema sides are 4. Ndo a quadrilateral, like a quad bike. A bike mdududu unema viri 4. Saka quad means 4. If we had a quadrilateral which is inside a circle, maybe let us say it's something like this. This shape is a quadrilateral, but it's not a cyclic quadrilateral. It's disqualified from being a cyclic quadrilateral, even though in a 4 sides, because we have only 3 corners, vertices, which are touching the circumference. So that is not, but this is. Okay. Now after noting, cannot discovering that you are dealing with a cyclic quadrilateral, be it to Mawood's one question or you have discovered it on your own, you then have to know how cyclic quadrilaterals fit into the story of circle geometry. So if we have cyclic quadrilaterals, you should know that opposite angles are supplementary. And kana chiti opposite angles are supplementary. The word supplementary in mathematics means adds up to 180 degrees. Saka ma side are opposite each other. They are supplementary. They add up to 180 degrees. This was zvamufanirwa kuziva kana tichitaura about a cyclic quadrilateral. So I'm going to remove this part. It was just a revision, a recall. Then we get into the business of the day. Now let us continue reading our question. In the diagram, ABCD is a cyclic quadrilateral in which AB is equal to AD and BC is equal to DC. Saka ndinowanzofarira kutrace zvinenge zvakanyorwa panapa. Saka zvanzi AB is what? Equal and to AD. Ndobva zvanzi futi BC is equal to DC. You can see that is what the diagram is reflecting. AC is the diameter and of the circle. Saka kana AC is the diameter of the circle, in most cases vanowanzokuuya panapa vobva vaisaka just can note up vobva vaisa O, because conventionally kumaseko O represents the sender. Samugona kuti panapa havana kuisa O, vataura kuti AC is the diameter. Saka you should be careful of situations where instead of kukuisirai O on a diameter, they don't put an O on a diameter, they just tell you that AC is a diameter. So AC is the diameter of the circle and ADB is equal to 10 degrees. So Azanzi, state the special name given to the cyclic quadrilateral ABCD. So the special name, of course, given to that cyclic quadrilateral, it's a kite. You are going to notice that that is a kite. Why do we call it a kite? Because these are the properties of a kite. Could we have two lines which are equal to each other, arunosangana on an angle, then we also have other two lines equal to each other, arunosangana on an angle. Then the typical case is this line is equal to that and this is equal to that. Then we are going to see the importance of this line which runs across, which in our case is a diameter. So it's a kite, there's no question about that. Then the advice I gave you earlier on when I introduced the topic of circle geometry, ndakati, before you look at the questions, just have a quick, less than a minute, rundown of my angles are obvious kwamuri. Just put them down. You don't have to put all the angles down. You just have to put my angles are immediately obvious. Sepanapa. The other thing, kana muchiita ma questions aya, please mufunga kutarisa what I refer to as a system of triangles. There is always a system of triangles. And by this system of triangles, you should look carefully at this phenomena of isosceles triangles. My isosceles triangles always make an appearance kana tichita circle geometry. Like panapa. An isosceles triangle, just to remember, it's a triangle with two sides equal to each other. And because two sides are equal, throughout these internal angles are also going to be equal to each other. That is what an isosceles triangle is. Saka mukadzoka kunoku, you are going to see kuti triangle ABD is isosceles because side AD is equal to side AB. Then the base angles of this isosceles triangle, imwe iri pana D pano, imwe iri pana B, which then means this angle is automatically 10 degrees. Then kana iyo angle iri 10 degrees, zvoreva kuti angle iyi haisi kuzonetsa kuwana. I can drag kumboisa iko zvino izvi, because remember panapa zvandiri kuita ndiri kungonyora ma angles are immediately obvious. Saka 10 apa. Then manje I can look and see kuti there is a principle I can apply panapa inotaura ichiti angles in a semicircle are equal to 90 degrees. Saka if angles in a semicircle are 90 degrees and semicircle inogadzirwa ne diameter, tells out AC is the diameter, kureva kuti this angle B, kana kuti angle ABC should be 90, kureva kuti this remaining part is obviously going to be 80 degrees. Mukuzona. Then the same applies here because this diameter is also creating an angle here, kureva kuti this angle is going to be 80 degrees. We subtract 80 plus 10, it be 90. But having seen that, you are also going to notice that DBC cannot BCD is an isosceles triangle because CD na CB are equal. Ndosaka pano paita 80, apo paita 80. In the same vein, this is going to be easier to get. Muruzona. Saka that is what we have done. Tisati tatarisa question. Now when it comes to looking at the question, let me remove this part which is not part of my answer. When it comes to looking at the question, zviri kunzi find part 1 ACD. Saka A, C na D. It's ACD. I'm going to shade the angle iri kudikwa. This is ACD. Do angle iri kudikwa. How are we going to find angle ACD? To find angle ACD, we should appreciate initially that kana tine a kite, there is a property of a kite which you should know. And remember that kite is a common appearance kana tichidila nema cyclic quads. Saka property yamufunga kuziva ndeyekuti this line, in our case it's AC, mufunga kuziva kuti AC is a bisector kana kuti in full angle bisector. Kureva kuti inodambura an angle into two equal parts. That is what it means. Saka AC chauya ichidambura angle kuno uku into two equal parts, ichadambura futi angle uku into two equal parts, because this line AC is a bisector. What it then means is, keeping this, of course, let me keep it kuitira kuti muzvirangarire. You can even write it in your notes, it's very important. Tikada kuita B in that light, muchaona kuti tikawana nzira yekucalculate angle BCD, and then we take half of angle BCD, tinenge tatova neangle yatiri kutsvaga ACD. Saka you can come here and write a short phrase calculating ACD, just telling the examiner zvamuri kuita. Then madaro machi put a semicolon pasi panapa, then put a working yekucalculate ACD. So calculate ACD akufangu kunetsa. Why? Because DBC plus BCD yatiri kuda kutsvaga. Alright, I'm sorry. Panapa I'm not calculating ACD for now. I'm calculating BCD. And to calculate BCD, then ndozotora half ya BCD ndiyo ichandipa ACD. Saka DBC, which is this angle, andika, plus BCD plus CDB should be equal to 180 degrees. It's a triangle. Then panapa, you know that DBC, this angle is 80 degrees, plus BCD yatiri kutsvaga, plus then CDB is also 80 degrees. 80 yabva pakuti this triangle DBC is actually isosceles. This is equal to 180 degrees. Kureva kuti 80 plus 80, that's 160. Saka 160 degrees plus BCD is equal to 180 degrees. Kureva kuti BCD is going to be equal to 180 degrees, subtracting 160 kenda kuside kunochinja from a positive to negative. So 180 subtracting 160 degrees, kureva kuti BCD is going to be equal to 60, 70, 80, 20 degrees. But isusu hatisi kuda, hatina kufunzwa BCD, tavunzwa ACD. Samogona kuti therefore ACD is equal to half of BCD. And mukada mogona kuisa a reason kuno kana kusaisa. The people who are marking your work, they are mathematicians, very intelligent. They can infer what you mean. But if you so much want to put a reason here, but if you have some reasons apo, if you are not really sure what you are doing, because sometimes my reasons cannot be in agreement with what you are doing. Sometimes they are vague and ambiguous. So it might cast doubts on your working. But I'm sure you're following what I'm doing. Saka ACD is very equal to half of BCD. This means this is equal to half of 10 degrees. Sorry, half of 20. Then that is working to give 10 degrees. Saka ACD is equal to 10 degrees. Dopanova that 1 mark. Mazviona. That is how it is done. There can be other ways of doing it. In mathematics, there are many ways of killing a cat, but I think this is the cleanest way of going about it. Okay, let us now do part 2. So this was A, B, part 1. Let me not remove the working as yet. Let me just put part 2 panapa. Different colors, I think you see the difference. Apo takuda kutsvaga chi ADC. Saka ADC. Muruzona. ADC is equal to ADB plus then plus G plus BDC. Like that. Saka ADC ingeri equal to kapata kakatain plus then of course BDC the 80, which gives us 90 degrees. Or you could actually have just written it like this. ADC is equal to 90 degrees. The reason being angle in semicircle. Mazviona. It's the angle in the semicircle. Correct panapa. This is an easy 1 mark, equal to 90 degrees. Sachandora tumubve nacho pakweseni ma properties a kite. Kuti this line is going to be a bisector. And the bisector wacho uripo kana this line or kana this line equal to that line. And we also have it as a bisector, kana this line equal to that line. If we have a situation like this middle line is going to be a angle bisector. That's the most important thing I want you to take from this question. Now let us look at this particular question. This was written June 2019. It was in paper 2. And it's also question number 2. In the diagram above, A, B, and C are points on the circumference of a circle, center O. AOC is equal to 3y, says watakapiwa, and ABC is equal to 4y plus 4. Part 1, write down an expression in terms of y for the reflex AOC. Chandora timbate, mofonga gona kuanza question. Question iri kudai, the demands of the question. Question iri kuda an expression. Kureva kuti it should be an algebraic statement. Question yenyu haisikuda kuti munyore equation. Iri kuda an expression. Saka expression yacho, you are just going to quote it and write it. Reflex AOC inenge equal to, remember angle at the center is twice the angle on what? On the circumference. Saka angle on the circumference there. More gonna reflex AOC will be equal to 2 times ABC. And there is an angle at the center is twice. My reasons are, I'll check it not on a reason. In fact, kuisa reason is serious might be more dangerous than kuisa reason. So be wise there. Angle at the center is twice the angle on the circumference. That is what we have. Apple. Okay. Saka panapa tinge takuti reflex, this is part 1, A or C is equal to 2 multiplying, because A, B, C is an expression, remember to use brackets. Saka 2 multiplying 4y plus 4. Correct answer inomakwa ndi 2 times 4y, removing brackets, 8y, then 2 times 4 plus 8. Iyi ndo answer inomakwa, that is the expression. Manzwisa ndiyo expression. And for the sake of continuity, it's best kuti move mango ya pano. Then you put this 8y plus 8. That's the reflex angle. Ndo zvinoreva kuti reflex izvi zvoreva angle iri opposite an internal angle. Okay, what does part 2 require of us? Find the value of y. Saka the value of y ainetsi, because we should know that angle at the center is a complete revolution, and a complete revolution is 360 degrees. Saka angle at the center is 360 degrees. Kuda kuti tikaedha maangles ari twaya anofanirwa kuti pa 360 degrees. 3y plus 8y plus 8 should be equal to 360 degrees. 8, 9, 10, 11. 11y is equal to 360 subtracting 8. 8 aenda kuside uko. 11y is equal to, let me use my calculator, paper 2. Saka 360 subtracting 8, we get 352 degrees. Divide both sides na 11. So rock to y is going to be equal to 352 divided by 11, 32. So y is equal to 32 degrees. That is going to be our answer panapa. 32 degrees. Saka it's not difficult. What I just want you, George, to focus on is presentation. Saka I'm not saying copy the way I do it, but derive inspiration from the way I do it, because I try to model ideally how you should present your answers for optimization. Saka munongoona maitirando and then you pick bits and pieces to express your answers better. Otherwise, the concepts, you are really a master at them. This is the second question. Panapa, maybe I can emphasize that this is not a cyclic quadrilateral, because only 3 corners, vertices, are touching the circumference. I think I explained this in our first question. Clear me to go to the next one. Let us now look at this question. This is a special question, wonderful question. Irikuti, in the diagram, points A, B, C, and D are on the circumference of a circle. In the corner of your brain somewhere, you should register cyclic quadrilateral. Panapa tina kudziwa, but this is the situation. Why is it so? Because A yakabata circumference, B yakabata circumference, C yakabata circumference, D yakabata circumference. Okay, then take note of that. Saka apa vanenge vatiudza indirectly, because vataura kuti points A, B, C, and D are on the circumference of a circle, center O. Very important to notice the center. And the moment patino ta notice the center, 2 things must register. Chekutanga, with the center tofanirwa kuziva kuti we now have a semicircle somewhere, because we have a diameter, not because of center but because of diameter. And what is the diameter? AC. Havana kutaura futi kuti AC is a diameter, muruzona. But a diameter, a line rinoita run through the center, but richibata A na C. Then pamunoona a radius, and apa we have many radii, but example would be OD. Just for you, OD is a radius, OC is a radius, OA is a radius. Mruzona. Saka maybe let me put all the radii we have. Saka pamunoona a radius tina OD, OC na OA, because kubva pasenda, line rinobva pasenda richibata circumference ndo radius. Pamunoona this radii, please ibvai maziva kuti you are most likely going to have a system of isosceles triangles. Ma-isosceles triangles vanomada singaite because ane a certain inference. The moment you see an isosceles triangle, you know automatically that you are going to have what? You are going to have base angles equal to each other. Saka they really love them. Be careful of that. Okay, so in the diagram, points A, B, C, and D are on the circumference of a circle center O. AOC is a straight line, and saka kuti AOC is a straight line, ndiko kutiudza kuti it's a diameter. It's a diameter. Then panapa wataura kuti A, B, C, D are on the circumference, ndiko kutiudza kuti we have a cyclic quadrilateral. And intelligible way of testing. Zvova zvanzi OD is parallel to BC, and OD is parallel to BC, and DAO is 30 degrees. Calculate these angles. Saka pataudzwa kuti OD is parallel to BC, chinjofanwa kuya musoro menyu, because we have a transversal line must set angles. Saka this information is inferred. Kureva kuti taipiwa information indirectly. Havana kutaura kuti it's a cyclic quadrilateral. Havana kutaura kuti tine diameter. Havana kutaura kuti tine a semicircle. Havana futi kutaura kuti because of my radius tine my isosceles triangles. Izvi munofangwa kuzviziva mega. So I'm going to leave that information up so that you can see where we are getting what we are getting. Okay, Saka, before we even look at my questions here, let us fill out my angles are obvious. I would say this angle is obviously 30 degrees. And I say that angle is obviously 30 degrees because OA is a radius, OD is a radius, correct, they are equal lines. Saka my base angles should be the same. You see what I mean? Base angles should be the same. Okay, but tikatarisa futi tikashandisa DC as the code, we are going to notice kuti angle iri pana A iri equal kune angle iri pana B. Saka panapa it's also going to be 30 degrees. Murukuzvoonaka? Alright, but we also see panapa kuti AC is a diameter running through O. Kureva kuti this should be a semicircle. Saka kana panapa iri 30, angle in a semicircle is 90. Kureva kuti this point should obviously be 60 and 789. So this is 60 degrees. Then of course this angle is going to be easy to calculate. And kana angle is easy to calculate, this also is going to be easy to calculate. Then kana angle takwanisa kuicalculate, angle E are going to be easy to calculate. And it's okay if you are not following, it's okay, don't worry. Then the other thing is OD, then the transversal line is BC. Kureva kuti this 30 degrees, panapa is also going to be 30 degrees, and that is so because of Z angles. That is so because of Z angles. Okay, saka taita fill in zvataona obviously. Let us now look at the questions. A iri kuda ODB. Saka ODB kureva panapa, it's 1 mark. Remember, ODB is going to be equal to 30 degrees, and the reason here is Z angles. So sometimes it's going to be as easy as just quoting. Alright, what about pa B apo? B vari kuda A, B, D. Saka A, B, D. This is the angle, and this is the angle ABD. And panapa we've seen kuti ABD is equal to 60 degrees. Okay, the challenge with kutanga maita few in my angles, in a way kuti you might then find it like you might need to just quote my angles acho pamunonyora ma answer, since mnenge matomaweka maybe in your mind, then mungoda kukota, but that is not encouraged. Saka I would advise kuti muise some form of working communicator kuti maita say, like in this case, instead of just saying ABD is equals to 60 degrees, you can rather say ABD and it plus then this angle is DBC should be equal to 90 degrees. Then your reason would be angles in semicircle. Reason munoisa kana mchida kana kuti amisi, it's to you. I would advise kuisa kana muri sure, kusaisa kana muri siri certain. Then panapa mogonova mati where then the angle DBC, saka where DBC is equal to 30 degrees, and the 30 degrees taiwana kupi, taiwana patati angles in same segment. That's the reason. Then mada is so much, therefore ABD plus 30 degrees is equals to 90. ABD is equals to 90 degrees minus 30 degrees. ABD is equal to 60 degrees. Saka mungadai so mnenge maratidza you're working. Otherwise munangosvika chinyora futi kuti 60 degrees, since it's the correct answer anowana futi mark yake, but awekawo kuti kuti aita mistake somewhere, ikakwanisa kutevereka mistake, maybe anowana half a mark or some part mark. So that is important. Okay, let us now look at C. Ndoda kuitira panapa kuti working yangu ive pan 1. Pasi tinoda kutsvaga ACB. Saka let us mark kuti ACB ndeipi. ACB. This is ACB. So how are we going to calculate ACB? Hama dzangu, apa ndo pakuchiapply nyaya yatanga tichitaura nezvayo. Tachitaura nezvechi? Nyaya yatanga tichitaura nezvayo inyaya ye a system of isosceles triangles. Saka what you can do here is muka calculator AOD. AOD make calculator say, since this is a triangle, AOD is a triangle, we need angle AOD. We are going to say 30 plus 30, 60. Then 180 minus 60 gives you 120. So this angle is 120. Then manje, panapa pa AOD, this is a straight line. Chiro question ya confirma. Kureva kuti, panapa takutsvaga angle on a straight line, which will just be 180 subtracting 120. And what is 180 subtracting 120? It's going to be 60. Kureva kuti angle iri panapa ndiani? Ndi 60. Saka in my original working pandanga this question before this lesson, I had data gymnastics panapa akawanda, but I'm discovering something easier because it's 1 mark. Kureva kuti working shouldn't be much complicated. DOC inenge equal to ACB because of set angles. muri kuona z iri panapa, maybe regai tiite trace out, saka iyi z iri apa ishi muri kuzoona. Haiziyo z yatashandisa pekutanga, z yatashandisa kwekutanga yanga iri ishi. Saka pane ma z angles panenge paine two forms of z angles. Saka z yekutanga yanga iri iyi, apa takuchishandisa the other set. Saka pano our answer is going to be ACB is going to be 60 degrees. Data msikanzo ndina kusa working. Ijaya kuti space yangu manje ndoda kuti zvangu zvive pano 1. But let me try to explain again the thinking. Thinking iri pano 120 taiwana from the triangle AOD. Tawana 120 tikazoshandisa tikazoti 180 minus 120 kuti tiwane 60 because aya maangles ari pa same straight line. 60 yacho ndo yatazoona kuti yakafanana neangle yatiri kutsvaga because of set angles. Saka ndo zvamunoita izvi. In the diagram, P, Q, R, and S are points on the circumference. Totarisa mapoints acho toona kuti ezvo R anditi R, S, P, Q. Kureva kuti tinechi tine cyclic quadrilateral. Imi and you don't have to literally write this. Of course, this is not part of your answer, but just tell yourself in your mind that we have a cyclic quadrilateral. Okay? Saka P, Q, R, and S are points on the circumference of a circle center O. Kureva we have what? We have a semicircle. Saka mogona kuregister in your mind kuti we have a semicircle. Zvichireva kuti angle in a semicircle is going to be 90, remember. Kana kuti the angle subtended by the semicircle is going to be 90. Taiwana kupi? Taiwana from the case of a diameter being PQ. Says wataudzwa kuti POQ is a diameter of the circle. Ndobva panzi arcs PS and SR are equal. Andidi. Saka kana ma arcs aya PS na, maybe let me write this. This is very important. You can put it as your notes. When arcs are equal, the chords which make them are going to be equal. Saka na ma arcs are equal, the chords which make them are going to be equal. That is, zoreva kuti line PS is equal to line SR. You can actually put some pointers here. Go to this line. It's going to be equal to that line. Very important. What you should then notice panapa is we now have a kite like this, and pakite pedu taona kuti this line which is SR is going to be equal to this line which is SP. And it's important to note that it is only SR which is equal to SP. Machona. This line RQ hatina kuudziwa kuti it's equal to PQ. That is important to notice, and you are going to see the applicability as we progress. Saka this is what we have been given. Apa ndachitsanangura kuti kana taudzwa kuti arcs PS and SR are equal, zvinoreva kuti line PS and line SR are also equal. Ndokuudzwa kuti QPS is equal to 57 degrees. Saka tichitanga, before we look at our question, let us fill in my angles are obvious to us. And remember, kuva obvious is subjective. Saka obvious kwandiri ke shouldn't necessarily be obvious kwa muri. That's why I try to explain so that you follow. Saka panapa, this is the angle subtended by the semicircle. Kuroti this is 90. Then kana iri 90 angle here ichanetsi kuwana because tavane a triangle in a two known angles, one unknown. Then the other thing, kana panapa iri 57 ino iri cyclic quadrilateral, zvinoreva kuti angle iyi 57 tika add ne this angle should give us 180, since opposite angles in a cyclic quadrilateral are supplementary. And if we do that with my calculator, theta I'm going to 180 subtract 57, we get 123 degrees. Saka panapa it's 123 degrees like that. Okay, Saka, do we have any other angle which is easier to fill in? Okay, if we calculate this angle, we are going to see that this angle should be equal to that angle. That's something we're going to see, and I'm going to explain what explains that. Alright, I'm going to remove kakaitaka because it's eating up my space. Then leave everything else for reference. Then let us go through this. Paragonze name the angle which is equal to SQR. SQR is this angle. And the SQR is equal to PQS. Saka panapa your answer, since vangonzi name, it's PQS. And please remember kusaka kepa kakari, very important. Why tiri kuti PQS iri equal to SQR? Let me bring back my kite. Saka kana kite yedu yakadai so, panapa tine this line, towards that this is equal to that. What this means, amadzangu, is parikusangana pa Q panapa, angle ino E is going to be equal to that angle. That is what it means. So you can do some research here and try to broaden this understanding. Please, I am going to look at the kite and produce lessons to describe the kite, because the kite is a special shape. The kite is a special shape. That's why in analytical geometry, in the book Nexus Practice Theory, when we do analytical geometry in advanced level, we start with two shapes, the rhombus and the kite. Saka, I'm going to come to you, please remind me, with a lesson explaining the kite, so that you might understand what it means. Because panapa tatuane two versions of a kite. Yatambeita yaya yanga ichitaura kuti kana this is equal to that and that is equal to that. Zoreva kuti line E is a bisector, but panapa it's not a bisector. Because this line is a bisector. Bisector kureva kuti rino dampura this angle into two equal parts, rodampura that angle into two equal parts, but panapa it's not a bisector. Kureva kuti angle iri pana AC hatitaridzi kuti panapa pana 90. You see what I mean? So this is important. I'm going to come with a lesson on kites, but for now, please take note of this difference. Take note of this difference. Saka these will be acting as root angles, because Q ndi ari producer achizono bodari R or producer of bodari P. Then P was on bata S, R was on bata S. Saka this will be the answer on this part. Part 2. Find PQS. Saka PQS nde ipi? PQS kureva kuti this angle. Saka iyo ichanetsa ere yama dzangu. PQS ainetse because panapa SPQ plus PQS plus QSP should be equal to 180 degrees. It's a triangle. But SPQ tapiwa ni question is 57 degrees plus PQS yatiri kutsvaga, then plus SP, QSP, ndo yataona kuti it's 90 degrees from being an angle subtended in a semicircle. This is equal to 180 degrees. Saka if I add 90 plus 57, I get 147. So 147 degrees plus PQS is equal to 180 degrees. Kureva kuti PQS is equal to 180 degrees minus 147 degrees. Saka 180 minus 147 is equal to 33 degrees. Saka tsitsi dzaitwa nekweseni tikuona kuti kana panapa pa tikutsvaga PQS, pa PQS iri 33 degrees, zvinoreva automatically kuti this is going to be 33 degrees since those two angles are equal to each other. Maapaona. Then let us see, takuda kutsvaga for our part 3, takuda kutsvaga QRS. Saka QRS iri papi? QRS. Saka QRS tatato calculator. Tukoona kuti QRS is equal to 123 degrees, but taiwana say QRS, tati QRS plus SPQ is equal to 180 degrees. Then reason yenyu is opposite angles in cyclic quadrilateral. And I have to write a reason so that kana makunyora ma notes you know what is happening. Saka if we solve this, tinoona kuti QRS inenge iri then equal to 123 degrees. But kudza mwana upedzisira ndizvo here, regai ndisolve. Saka kana ndakuda kusolva panapa, we know kuti QRS ndiani? What is QRS ndo yatiri kutsvaga, but SPQ ndi 57. Saka tiri kuti QRS plus 57 degrees is equal to 180 degrees. Kureva kuti QRS is equal to 180 degrees minus 57 degrees, which then gives us 123 degrees. Andika? Okay. Our last question, number 4. Find QSR. Saka QSR is this part. But QSR ichanetsa here amadzangu. QSR ifangu kunetsa because of how obvious it is. Kana takuda kuwana QSR, we are going to add QSR plus 33 degrees plus 123 degrees should give us 180 degrees. Saka QSR inge equal to 180 degrees. You can do it like this, minus 33 degrees minus 123 degrees, even though I usually avoid this because it can be a harbinger of unnecessary errors. Saka the answer here is 24 degrees. So this is what we are getting panapa. Saka this confirms zvananga taura. This line is not a perpendicular bisector because my angles are yakasiyana. Number 2, even though kunoku iri 33 but kunoku it's 90-24. So this is not a perpendicular bisector. Inova perpendicular bisector kite kana this line equal to that and this being equal to that. But I'm going to bring more knowledge on kites, so you don't have to worry. Okay, Saka, we have done our tutorial on circle geometry. I now extend an invitation to those who want to join us in extra lessons. If you want to join us to have more closed door personal one-on-one lessons, you can WhatsApp us on this number and we see how best we can help each other. Number yacho it's Zimbabwean, but I'm going to write it with the code. It's plus 263 71 521 3310. And please, this only works on WhatsApp. Thank you and take care. I have decided to double down on this question, but ndoda kutarisa C. Saka ngatitei C zvakare. Chiripo chekutanga, before we get into C, I want you to take note of the explanation I had pataita C for the first time, where we discovered that C is going to be 60 degrees. And I also want to fill in my angles esatanga tawana. Remember, this angle is 30 degrees because triangle AOD is an isosceles triangle. Saka triangle yatenge tichitaura nezvayo panapa, if I trace it, is this triangle ish. This is an isosceles triangle. Why is it an isosceles triangle? Because tikatarisa OD tunaona kuti radius, tikatarisa OA tunaona kuti radius. Saka because triangle AOD is made up of two radius, which are two equal lines in length, so the base angles of this isosceles triangle are going to be equal. So we had discovered that. Then the other thing we did was taona kuti this angle is 30 degrees. And iri kubva kupi? Iri kubva pakuti tikashandisa the minor arc DC kana kuti the chord DC, tinoona kuti this, and I want to trace it like this, then toya panapa todai. Saka angle E and this angle, they are what? Angles in the same segment. That is why this angle is 30, taking it from this angle A, kanaguti TAO, DAC, which is 30 degrees. And then manje, from that we also saw kuti this angle is going to be 30 degrees. Tazona kupi kuti angle yo inenge iri 30 degrees. Zvabva pa this Z angle, which I am tracing like this Z angle. Saka kana E iri 30, zvoreva kuti E is 30 futi, because it's a set angle. Saka we did take note of this set here, kuti this angle being 30, this angle should also be 30. Okay, Saka if we just want to have a brief on set angles, remember tinenge tine two parallel lines, like in our case OD is parallel to BC. Then from that we have what is called a transversal line. A line rinongodambura nepakati apa, like this. Saka what it means is we have to trace a set, saka chinzi set angles. Tikadai so, todai. Saka we are tracing a set. This angle is going to be equal to this angle. Ndozvaitika panapa, set yedu yabuda, saka angle E30 is equal to that angle 30. Okay. Now, taona says when we wanted to find ACB, and if we have to take note of ACB and the ACB, this is ACB. Saka patanga tida kutsvaga ACB, zvataita in our earlier method, tatanga tatsvaga this angle, ndova angle itaona kuti it's going to be 120 degrees. Iri kubva pakuti this is a triangle, and taona kuti this angle is 30, that is 30. Saka this is a classical case yekutsvaga an angle when we are given two angles inside a triangle. Saka the equation is just going to be 180 degrees, which is the sum of angles inside the triangle, subtracting 30 degrees plus 30 degrees. Ndiyo yatipa 120 degrees, which happens to be angle yatiri kutsvaga AOD. Andika panapa ndazvinyora hangu ndichiita cluster, but I understand you get it. Then kana takuda kuziva kuti ko angle iyi inenge iri chii, this angle haichanetsi because AOD is a straight line, it's a diameter. Kureva kuti at O, we know that the sum of angles on a straight line, cannot angles on a straight line, it's 180. Kureva kuti if we just say 180 degrees subtracting 120 degrees is equal to 60. This 60 is angle DOC. Andika saka apo tazoona kuti i60. Then ndobva tazo discover kuti tiri pa set angle panapa tikaitrace a different way. Tikatangira pana D tichienda pana O. Let me try to use a color I haven't used before. Saka tikatanga pana D tichiuya pana O panapa toata daiso todai, tinoona kuti this angle is going to be equal to that angle. Ndo reasoning yatashandisa kuti this is 60 degrees, and it's correct. But what I want to show you as my method number 2 is that tinogona kushandisa angles in the same segment. Saka nishandisa angles in the same segment, muchaona kuti, let me try to find a color here. Muchaona kuti if we have angles and tikadai so, then we have a chord panapa, and then we are going to have a situation like this. And saka angles in the same segment inge chitiudza kuti this angle, angle is the same as this angle, because tinenge taona kuti these are angles in the same segment if I am to trace like this. But you should also take note kuti apa tinenge tashandisa this chord, which in our example is AB. But kana kuno kwakaiswa futa another chord, kureva kuti tine another minor arc, which in our example is DC. Tinogona kushandisa DC kudai so. Tikada kutrace like this, you are also going to see kuti this angle is going to be equal to that angle. Saka pane duality, pane kutoredzerana kwekuti tashandisa DC as our chord, ndo yatiudza kuti angle iri pana A yakafana angle iri pana B. Tinogona kushandisa AB as our chord, ndo inotiudza kuti angle iri pana D yakafana angle iri pana C. Saka tikadaro answer yedu inenge yakubuda straightforward, tisina tomboita zvandaita panapa zvekuzoshandisa set. Tinogona kungoti angle yatiri kutsvaga ndi ACB, saka ACB inenge iri equal to ADB, and our reason is what? Angles in same segment. Okay, manje ADB, where ADB is equal to, tikatarisa ADB tunaona kuti ine a part of ADB ndi 30, which is ADO. Turn out we have to add that to ODB because another part is also 30. So 30 plus 30 is equals to 60. Therefore, ADB is equals to 60 degrees. Saka indo yanga iri mwenzira yatachikona kushandisa, iri quite more easier kuti taona kuti angle iri panapa yakafanana neangle iri apa. Saka 30 plus 30 is equals to 60, yotipa that 60. Imwe nzira inogona kushanda panapa ndei, remember hatisati taziva kuti this is 60, ngatiti toda kutsvaga 60 panapa. Iyi nzira inotenderera, but sometimes tinogona kunonoka sezvandaita kunonoka kuona nzira dziri kuika, saka must tinopesera takuita nzira dzinoita sedzekutenderera. Chakakosha kusvika paanza. Saka I'm sure kuti mese maona kuti 30 tinoiwana kupi, handiti 60 tinoiwana kupi. 30 taiwana from set angles, 60 taiwana from angles on a straight line. Tinogona kucalculate kaangle aka. Tikacalculate kaangle ako tenge tichiti 180 subtracting 60 plus 30, because triangle ishi DO kusvika papoint katriangle kadika. Taziva kuti angle iyi 30, tikaziva kuti iyi angle iyi ichi i60. You get it? Saka takuda kuziva kuti kaangle aka kanenge kari chii. Saka 6, 7, 8, 9 kureva kuti angle iyi iri panapa it's 90 degrees. Saka maona kuti angle iyi 90 degrees, mukashandisa principle yaya inotaura ichiti opposite angles on cross section are equal. Illustratively techidai so angle iyi kana iri theta, ino inenge iri futi theta, they are equal. Then iyi angle iyi tikaiti ndi alpha, ino futi ndiani ndi alpha. Saka the implication here is kana panapa angle yatacalculate iri 90 zvoreva kuti ino ifuti ichi i90. Saka kana takuda kutsvaga C iyi takuchishandisa triangle B kusvika apa C. Saka teta kuti 90 plus 30 towana 9, 10, 11, 12, 120. Then tikazoti 180 minus 120 toza kuti 8 minus 26 inongobuda futi iri 60. Saka there are many ways of doing this. Which one do I encourage? The one which comes to you the earliest. So I have showed you 3 methods. Yekutanga we discussed it. H2 tashandisa angles in the same segment. Then H3 tashandisa angles on cross section. Because apa ndi 90 yatacalculate from this small triangle, kunoku ndi 90 futi, saka 30, 90 apa inova 60. 3 different methods producing the same answer. That's the beauty of mathematics.